What has our study of informal fallacies of reasoning taught us? Just this. Trying to reason validly using only informal reasoning is fraught with danger and uncertainty because of the special problems of relevance of premises, or presumption in those premises, or ambiguity of words, phrases, and even whole sentences. Informal reasoning does not always guarantee a valid conclusion drawn from those premises. So wouldn't it be nice if we had a foolproof way, a recipe, much as people use when they make cookies or pizzas, something that we can rely on that's always going to give us a valid argument every time we use that recipe or that form? Well, that's exactly what we're going to study now, because we now come to the fundamental core technology of reasoning in this class. It's called standard form categorical logic, also known as Aristotelian categorical logic. And it was formulated by Aristotle based upon three laws of thought that were derived from ancient mathematics, like the work of Pythagoras. The principle of identity, the principle of non-contradiction, and the principle of the excluded middle. Don't worry, you'll learn these along the way. But for now, it's important to realize what categorical logic is. Categorical logic is the study of those forms of reasoning, those sets of reasoning, those arrangements of premises and conclusion that yield a valid argument time after time, regardless of the topic. Because as a critical thinker, that's where we want to start. We're in search of sound reasoning, valid arguments with factually true premises, but let's start with making certain that we always have a valid argument. Thus, categorical logic will give us this. The fundamental idea of categorical logic is based on the notion of category or class or group inclusion or exclusion. For instance, take the example, all dogs are mammals. We understand that's what it means to say that everything that is a dog, every member of the class of thing called dog, is also a member of the class of thing called mammal. But it does not follow, does it, that everything that's in the class of mammal is also in the class of dogs. So for instance, if I said all dogs are mammals, and then I turned around and said, but all mammals are dogs, we'd have a problem. So there are guaranteed forms of reasoning that we can use in argumentation time after time, regardless of the content. It doesn't matter what the topic will be. If we use these forms of standard form categorical reasoning, we will produce a valid argument every single time, guaranteed without mistake. And really, that's the place to start as a critical thinker.
All right, then. Here in week number 2 of our course, we're going to be looking at some formal structures of reasoning, one called deduction, one called induction. Now, we know that a deductive process is any process whereby a set of premises, if they're true, if they're factually true, imply a conclusion by logical necessity, in which case we would have a sound argument. A sound argument is a valid argument with all factually true premises. Right, we got that. Exam number 1 proved that. The other formal structure is the process called induction. Now, this is the process by which a series of premises, not just 2, it could be a whole bunch of premises, could be hundreds of premises, that allow us to make a conclusion based upon probability, mere probability. Not certainty, but probability that the conclusion is acceptable and workable and true to the best degree of our knowledge at the present time. You've heard the expression, garbage in, garbage out. Well, that's what's going on in inductive reasoning. If you have bad or weak premises, data in your analysis, the chances are, the probability is that the conclusion is also going to be weak. Right? So induction and deduction differ in that sense. So the first thing I'd like you to do, whenever you're presented with any argument whatsoever, where you see the word therefore, and then somebody says, this is the case. Wherever you see a therefore, ask yourself, Does that therefore sentence, proposition, does it claim absolute certainty based upon the validity of the premises driving the conclusion, or does the therefore conclusion only offer us a degree of probability? If it's the former, it's deduction. If it's the latter, it's induction. It's a very simple test. You can't go wrong. Now, inductively, arguments can range from all the way from worthless on the one hand because of really bad data and really insufficient research and not enough observations being conducted, to absolutely highly probable conclusions based upon hard data from the hard sciences. I would say physics would be the hard science, chemistry, biology, computer science, absolutely. These are hard sciences. These are sciences that we can make many observations and derive from those observations probabilistic conclusions. On the other hand, the social science, so-called social sciences, some even debate whether they are sciences, they're so weak. They do not have the same level of observables and empirical verification standards. I would say sociology, even economics, psychology certainly, are more opinionated based than they are data and factually based. Now, there's a great deal of attempt these days in modern universities to try to convince us that sociology is a science or that economics is a science. Well, all you have to do is to ask this one question. Do the conclusions of any of these social sciences yield absolute truth? And just wait for an answer. They don't. They only give you degrees of probability. We will examine analogical inductive reasonings and causal inductive reasonings when we get to the week number 4, which is refutation. We'll show you how to use the processes of logic to demonstrate that inductive reasoning is either very strong or very weak, but is never valid or invalid. All right. So let me give you an example of an absolutely weak, worthless inductive argument, just so you can see how an inductive argument functions, where you can see the little gutty what, the little logical gutty what that's inside of an inductive argument. Suppose I were to say to you, my little brother Tommy told me today that he saw an invisible witch in the garage as he was changing a tire. Then Susie Cupcake, right across the street, yeah, she said that she saw an invisible witch too in her kitchen when she was baking chocolate chip cookies this morning. And my dad, he came over from the golf course yesterday and he said he saw an invisible witch when he was lining up the putt on the 9th green. So therefore, I conclude it's highly probable that invisible witches, there are a lot of them, and they're everywhere. Well, obviously, based upon the premises of seeing something that is invisible, a contradiction right there. So the premises are just thrown out as being not only weak, but also absurd. I use absurd examples to show you the mechanism of the structure. Now, at the other end of the spectrum, we would have an example of a very strong probabilistic conclusion based upon observable researched evidence scientifically from, let's say, the realm of statistics. Suppose we were to say that, for instance, the city of Salem, Massachusetts has been keeping records for 300 years. And over this period of time, looking at those records, we can plainly see that more people over the age of 25 turn out to vote in the city elections in Salem, Massachusetts than people under the age of 25. Now, let's say the next premise is, therefore, based upon the fact that there's a city election next week, we can probably predict that there'll be more voters over 25 years of age than there were under 25 years of age, based upon the historical record of the voting patterns of the city of Salem, Massachusetts. Now, that's a very probable guess, estimate, but it really is a guess. it really is an estimate, because it may be that for some reason there's a very young candidate who's running in a city election and brings out more 25-year-old and under voters than over 25 voters. So you can see that even though things look pretty good for that particular argument, it seems strong, it's not absolute. So here's what to remember for week 2. We're going to be examining logical structures that are both deductive and inductive. Keep them separate by simply looking at the conclusion. Ask yourself, am I being sold certainty, logical certainty, that this conclusion follows validly from these premises, or am I being sold or being promised probability on a scale of, let's say, 1 to 10? That's induction.